All right, now let's do the quotient rule, okay? And just like we did with the product rule, I'm gonna use some highlighting here, okay? Now, instead of taking the derivative of a product of two functions, the quotient rule is gonna have us take the derivative of a quotient. Yeah, of course, right? So now this one isn't 1d2 plus 2d1. This one's gonna be a little bit different. So let's make sure that we're on this one. This one is, and I'm gonna switch it up a little bit. This one's low d high minus, don't get tripped up by that minus high d low all over low squared. Yes, I don't spell correctly. I get that. Low d high minus high d low all over low squared. And whenever we have that d, remember that d means derivative, right? So we're going to low, right, the low function or the denominator function, d high, derivative of high function, minus. Don't forget the minus. Oops, that's supposed to be blue. It's not blue. I mean, it's supposed to be yellow, not yellow. All right, low d high minus high d low all over low squared. Okay? So just make sure to get that one. 1d2 plus 2d1, low d high minus high d low all over low squared. Okay? Good? Good? Good. Let's go. All right, let's example D. Not to be considered with, or be confused with derivative. Example D. We could call it example derivative, I guess, if we wanted to. Example derivative. Find the derivative of f of x if, right, we get high function 4x to the second minus 5x plus 12 over low function x to the third power. All right, so let's do it. F prime of x, right? This is going to become, this left side of the equation is going to become really important, okay? We're going to have to watch that. So I think some of us are maybe not paying as close of attention to that. But we will focus in on that a little bit more. It's going to mean more to us, okay? So f prime of x equals low, d high minus high, d low, all over low squared. Low. We're just copying. Straight copying low. X to the third power. D high. Now, did you notice that high is separated by pluses and minus signs? They're individual terms. So I can take the derivative of the high function individually, right? Just like my power rule, or using my power rule. So 4x to the second power is 2 times 4 is 8. X to the 2 minus 1 is 1. 8x to the first power minus 5, right? X to the first power. And the derivative of 12 is 0. So there's low d high minus sign, not plus, minus sign. High 4x squared minus 5x plus 12 times d low. D low function is x to the third power, so 3x to the second, if I subtract 1, right? And then I got to put that all over the low function squared. And when you put the low function squared, make sure that you put parentheses around it, okay? All right, I don't want this looking like x to the 32nd power, all right? Now, just like we did with the product rule, you'll get plenty of opportunities to simplify these sorts of things, right? You could take x to the third power up here and distribute there, and we could take 3x to the second power and distribute here, and then do a whole bunch of combining and take x to the third power squared, and then we could probably have some fun simplifying beyond that, okay? But for now, let's just leave it like this. All right? I think we have 2 more examples, E and F. Yeah, let's do E and F here. E and F. Find the derivative of f of t. Ooh, new input value, right? Did you notice the t there? So we got a numerator and a denominator, or a high and a low, right? So, oh, what else do you notice about this one? Did you notice that numerator? What do I have up here? I got a root. And when I have a root, I want a root for you to change that to a fractional exponent, right? So let's rewrite this one first. I'm going to rewrite this one. F of t equals, that's t to the first power square rooted. So t to the first power square rooted is t to the 1/2 And let's, oh no, denominator's good, right? 6t to the third power minus 8t. 8t, not 8e. Ha! All right, now, woo! I almost got tripped up on that one, didn't I? Now I think I got a low d high minus high d low situation going on here. All right, so let's do it. Derivative of f of t is f prime of t, and I still wrote x. Good job, Wallace. F prime of t. All right, equals. And we're doing, it's a quotient, low d high minus high d low all over low squared. So low, I just copy, right? 6t cubed minus 8t. D high becomes a little bit easier now that it's t to the 1/2. So 1/2 times 1 out front is 1/2. T to the 1/2 minus 1, or 1/2 minus 2/2 is what? Negative 1/2 power. So low d high minus high t to the 1/2 power. Copy that guy. And then derivative of low. And again, the derivative of low is two individual terms. So I can take the derivative of those individually. 6t to the third is what? 3 times 6, 18. T to the 3 minus 1 is 2. And then negative 8t to the first is negative 8 t to the 0, but I don't need that. And I can put that all over the low squared. The low, and this is another example of why putting the parentheses is good, because we want to put 6t to the third minus 8t in parentheses, right? When we multiply that out, do you see 4 multiplication problems if we were to do that? 6t to the third minus 8t times 6t to the third minus 8t. So, yeah, parentheses. Important stuff. All right? Example E, questions. F. Not your grade on the next assessment, but let's just do example F. All right, do you see a division? Oh, I assume that that's supposed to be 10x to the 7th. Look at that. Let's go with 10x to the 7th. I'm not sure what you have on your pages in front of you, but let's go with 10x to the 7th just for funsies. Okay? We want to find the derivative of that. Now, did you notice here? I see 5 over x in the middle of that term there. And that 5 over x is, I think, going to cause us problems, right? That is really, actually it's negative 5 over x to the positive first power. And so I want to rewrite this as a negative exponent to be able to help me out. So let's rewrite y. Y equals 4x I'm not changing. This is going to be still minus 5, right? That's my coefficient. But x is now going to be to the negative first power minus 10 over, remember, 10x to the 7th. I don't know why that x didn't copy over, but it didn't. Okay? Now, hopefully we see a good enough top function there and a good enough bottom function there to get our low d high minus high d low all over low squared. All right? So let's focus on the left, right? Y, derivative of y is y prime for now. And low d high minus high d low all over low squared. Low, copy low. 10x to the 7th. D high. Derivative of 4x to the first is what? 1 times 4 is 4x to the 0, or just 4. Negative 1 times negative 5 is positive 5, x to the negative second, right, if we're subtracting 1, right? And then the derivative of the constant 10 is 0. Minus high function. So let's copy high. 4x minus 5x to the negative first minus 10. And then we can take the derivative of low. What do we have? 7 times 10, so 70x to the 7 minus 1 is 6 power. So there's low d high minus high d low all over. And again, I'm going to use parentheses here for low squared. Low is 10x to the 7th, all squared. And again, if I was to square this out, right, it would be 10 to the second power, 100. x to the 7th to the 2nd power, x to the 14th, right? You got to do both, not just one of them. So, okay. So there is D, E, and F, and I think you get 6 more funsies. All right? So those 3 examples for quotient rule. Now you do some fun, have fun with those next 6.